Hello, welcome to Driving Academy. In today's class, we'll be continuing our differentiation class. In our last class, we learned about the first principle method of finding derivative of differentiating from first principle. Now in this class, we'll be looking at the general method of differentiation. We're going to look at the general method of differentiation. So let's go. Now, the general method of differentiation is if y is equal to x raised to the power of n, dy dx is equal to nx raised to the power nx n minus 1. That means the power here, which is n, is going to multiply the x here, which is this, then subtract 1 from the power. That is the general method of differentiation. Instead of going through the first principle procedure that is very lengthy, you can simply come and use the general method of differentiation to give you your answer instead of going through that long process. Unless it is stated that you should use what? The first principle method. But if it is not stated, you can simply use this particular formula here to find the derivative of your what? Of your y function. Easy enough. So let's look at an example. Let's apply this formula. Alright, let's apply the formula. And the example, find dy dx, which is the derivative. Find the derivative, which is y dx, if a y is equal to x raised to the power of 4. Find dy dx if y is equal to x raised to the power of 4. So let's start. Solution A. Now the question is, we should find dy dx if y is equal to x raised to the power of 4. So y equal to x raised to the power of 4 is the solution here. Let's compare this function to this function. If we compare it, say that y is equal to x raised to the power of n here. Yeah, n here is our power of x. Now if you look at this, what is the power of x here? It's 4. So since 4 is the power of n, you can simply say that from this equation, n is equal to 4. Alright? Since n is equal to 4, let's get the y dx. We say that the y dx becomes, the y dx here will be equal to, say n, which is, n is 4 here, becomes n, which is 4, multiplied by x, then n minus 1, so it becomes, n is 4, so it becomes 4 minus 1. So this will give us dy all over dx will be equal to 4x. 4 minus 1 will give us 3. So therefore, if we differentiate y equal to x raised to the power of 4, we are going to have our dy dx will be equal to 4x raised to the power of 3. So this is how we solve for the first one, which is A. Next one is, let's go to our B. Now B says, find dy dx if y is equal to x. Find dy dx if y is equal to x. So y equal to x. So let's use the general method to find dy dx if y is equal to x. So from here now, we said that the formula has n, right? From general, n here. What is our n here? There's no power stated here. So since there's no power, what is n? Remember, this is the same thing as x raised to the power of what? 1. Same thing as x raised to the power of 1. Since it's the same thing, you can simply say that n here becomes 1. So if n is 1, you can simply say that our dy all over dx here will be equal to 1, which is because n here, our n is 1, so it becomes 1 multiplied by what? X. So 1 times x, then n minus 1, n is 1, so it becomes 1 minus 1. This will now give us dy all over dx will be equal to 1 times x will give us what? X. 1 minus 1 will give us what? 0. So this will give us dy all over dx will be equal to x raised to the power 0 will give us 1. Why is it 1? Know that anything raised to the power of 0 is 1. If it is 100 raised to the power 0 is 1. 1000 raised to the power 0 is 1. So just know that anything raised to the power of 0 is 1. Since that is the case, x raised to the power of 0 will give us what? 1. So therefore, our answer here becomes 1. If we differentiate y equal to x raised to the power of 1, we are going to have dy dx will be equal to 1. So this becomes the answer to B. Next step is C. Says find dy dx if y is equal to x raised to the power of what? Minus 2. C said that y equal to, this is the C, y equal to x raised to the power of minus 2. Now, since y is equal to x raised to the power minus 2, let's compare it to this general method. Yeah. So y is equal to xn. Yeah. Then y is equal to x minus 2. From here, when the power of x is n, power of x is what? Minus 2. So automatically, n here becomes equal to what? Minus 2. Becomes minus 2. So let's get dy dx. Our dy dx now becomes nx, right? N here is minus 2, so this becomes minus 2 multiplied by, because this is n multiplying x. So minus 2 times x, then n minus 1. Our n is minus 2, so it becomes raised to the power minus 2 minus 1. Minus 2 minus 1. So dy dx here becomes minus 2 times x will give us minus 2x. Minus 2 minus 1 will give us minus 3. So if you differentiate y equal to x raised to the power minus 2, our dy dx becomes minus 2 times x raised to the power minus 3. So this becomes the answer to the C. The next one is our D, which is if y is equal to the root of x, find dy dx. D, if y is equal to the root of x, find dy dx. So if you look at this now, unlike the remaining A, B, and C, where the function is stated boldly, this one they give us what? A square root. This particular one they give us a square root. So how do you go about it? This becomes y will be equal to. Now from indices, right? From lots of indices, we said that the root of x is the same thing as what? X raised to the power of 1 all over 2. So anything raised to the power of 1 over 2 is the same thing as what? The square root. Anything raised to the power of 1 over 2 is the same thing as square root. Then anything raised to the power of like x raised to the power 1 over 3 is the same thing as what? The cube root of x. So in the same scenario, since this one is the square root of x, the same thing as x raised to the power of 1 all over 2. So therefore, if we compare it with this, our n here becomes 1 over 2. So this becomes, from here, our n is equal to 1 all over 2. So since n is equal to 1 over 2, let's find dy dx. So what would be our dy dx? Dy all over dx will be equal to, remember we said n here, our n is 1 over 2, so it becomes 1 all over 2 times x. So that is x. Then 1 over 2 minus 1. 1 all over 2, which is n minus 1. N is 1 over 2, so it becomes 1 over 2 minus 1. So this will give us dy all over dx will be equal to 1 all over 2 times x. 1 over 2 minus 1. Well, 1 over 2 is half of 1. Then 1 over 2 minus 1 will give us 1. What is the LCM here? The LCM here is 2. The LCM times 1 over 2 times 1 over 2 will give us what? 2 times 1 over 2 will give us 1. 2 times minus 1 will give us minus 2. So in that case, our dy all over dx becomes 1 all over 2 times x. Then 1 minus 2 will give us minus 1 divided by 2. So 1 over 2 minus 1 we have minus 1 over 2. So therefore, if we differentiate y equal to the square root of x, the dy dx will be equal to 1 all over 2 times x raised to the power of minus 1 over 2. So that is how we use the general method. Now, our next class now will be on the rules of differentiation. Our next class will be on the rules of differentiation. Thank you.